Hi, my name is Erin Scott, and I'm a PhD student at the University of Arkansas. Today, I'm going to talk about cost-benefit analyses of manure management systems. And this economic analysis is part of a larger collaborative research effort to develop a decision support tool that can be used by farmers as well as consultants and policymakers. And today I'm going to focus on methods to evaluate capital costs of solid liquid separation. Dairy farmers have always been in the business of producing and selling milk, with a long history of returning manure nutrients back to the land for crop production. But due to the growth in farm sizes and increasing regulatory or other pressures, typical collection, storage, and land application activities may be problematic. And additional manure processing might be needed, but farmers also need good information and tools to make best business decisions in managing these valuable nutrients on farm. There are a lot of opportunities for cost savings, revenue generating co-products, and environmental stewardship, but there can also be high costs associated with these manure management opportunities. The purpose of this study is to develop cost-benefit analyses for multiple manure management technologies and processes. And like I said, this analysis will integrate into a decision support tool along with environmental impact and technology criteria. And this chart shows some of the sub-criteria that we consider for each of the main criteria. And so the economics will look at capital costs, operational costs, cost savings, and revenue potential. So for this project, we are considering all things manure. So looking and evaluating everything from collection to treatment and storage to land application. And like I said before, for this talk, I'll focus on modeling capital costs for different solid liquid separation technologies. Solid separation removes coarse solids from the liquid stream, and this can be valuable because it reduces manure volume going into storage, and so it can reduce the sludge buildup in the lagoon, as well as reduce odors. And it can also reduce bedding costs and the cost of transportation and application to the land because there's less water in the solids, and also liquids can be pumped rather than hauled to the field. But separation also comes with added investment and operational costs, as well as the management of now 2 different waste streams. And so the economic analysis will help understand the trade-offs between these costs and benefits. So in order to do this, we need to first define what those costs and benefits are. Focusing on costs of solid liquid separators, we want to be sure that we account for all of the major cost components. And a big challenge I have, well, my background is on surface water quality and not on agriculture or economics. So I'm still, getting a feel for this terrain and how data collection goes and sort of what the important economic factors are. And so from the literature and reports and the data that I have collected so far, it looks like the major cost components for solid liquid separation includes the separator itself, the installation of the separator, other equipment that is not in the list price for the separator, so things like washers or sprayers, electrical, and installation for these things. Adjacent infrastructure, which would include concrete slabs and building and other earthwork, plus that installation, and then transport of manure into and out of the separator system. And I will say I am happy to receive input from others who have alternative suggestions to these components or to this overall approach. So after we've defined what those major cost components are that are important to the economics, we need to assign values. So I'm currently collecting data for each cost component and plan to model these for each separator type that we're evaluating and across a range of farm scales. So under perfect conditions, I would have reliable and comprehensive cost information for all the important cost components for all types of separators and under the proper range of farm sizes without gaps in data across scale. So I quickly found that data collection is challenging, and I cannot expect this level of data, especially when considering I'm doing this similar analysis across several other manure management technologies. So a question I'm trying to answer is, where should I direct my focus for data collection? We have opportunities to work with industry partners who may provide cost estimates, but their time is extremely valuable and our request needs to be focused. So just generally, I'd like to know, how do costs change with scale? So maybe we can focus our efforts. And so are there breakpoints where costs increase more significantly at certain farm sizes? And if so, what are those breakpoints? For example, do these make sense? 100 cows, 200, 500, 700, 1,200, 1,500, 2,500, and 5,000. Are there significant breakpoints at these farm sizes? And another challenge is we are looking at swine operations as well. So we'll be having to evaluate sort of different animal types and numbers of animals. And then one other question I have is, do these, if there are breakpoints, do they really matter based on the variability in cost due to other driving factors? So even if we know that costs will increase for a separator from, say, 400 to 500 animals, will that cost be visible when considering differences in other factors? So if we look at this little graph on the lower right, yeah, if I know that I just need one separator up until 400 cows, and then after that I need two separators, so the cost per cow, you're going to see that sort of quick increase. But just in my data collection efforts, am I going to be able to capture that type of shift if there's, depending on the level of variability just there is inherently in costs across farms? So I do have some preliminary data to present for a two-stage separator, which is a slope screen followed by a roller press. These four graphs represent the same data set for modeling capital costs of a two-stage separator. And this would be total capital costs, but I would have similar sorts of data for each of those cost components. The two top figures show total capital costs. The two bottom figures show capital cost per cow. The left panels show the number of animals as the explanatory variable, and the panels on the right use volume of manure processed. And so the point of this slide is not necessarily to look so closely at the costs, because there are some qualifiers to these data that I need to address before I actually, finalize this evaluation. But rather, really the point here is to express a question, and that is, what's the best explanatory variable to use to model this information? I've seen it done with number of total animals, number of milking animals, and manure volume processed. And so, having data reported in these different ways makes it kind of hard to use literature data to build models. But then also just generally, what is the most realistic and meaningful way to model capital costs? So ultimately, the goal of all of this is to calculate costs for each of those major cost components within a technology or process and present this economic output to the person using the tool. So really, the output will address the relative differences between different options for alternative manure management, and is certainly not intended to provide actual cost estimates for any given farm. But we still want this, these economic outputs to be valuable in some way. And a final question I have right now is, what economic information is most relevant to farmers? Are they interested in comparing options based on a total recovery value, or which is like an annual cost of ownership? Or are they interested in something like net present value that evaluates cash flows over a given period of time, like 5 or 10 years? Again, these results, whatever they are, will integrate into the decision support tool and will be presented to the user. So right now, it seems like I have a lot more questions than answers. And so next steps are to find answers for these questions and also obtain reliable cost data to really start modeling the solid separation equipment. And then after that, I'll move on to other manure management technologies like anaerobic digestion, fine solids recovery, and water recovery. So I'd like to thank the USDA, National Institute of Food and Agriculture, for funding this research. Also, a big thanks to my research partners on this grant for their guidance and support. And then finally, thanks to you for your time. I'll try to answer any questions you might have, but I also want to say I'm very interested in any comments and suggestions right now or in the future. So please feel free to contact me by email or phone, which is shown up on the screen. Thank you.